Hello everyone, my name is Ranjit Nishad. Today I will be presenting my internship project on predicting salary for the data professional using machine learning techniques. This project encompasses EDA, feature engineering, model development, and evolution. The, project, the objective of project is to build a predictive model for the salary of data professionals, and the goal is to help the job seekers and employers to understand the salary trends and make informed decisions. The dataset includes the various attributes such as the personal information, job detail, performance matrices, and the target variable, which salary of the data professional. EDA is a crucial step to understand the data underlying structure. We will look to summary the statistics, visualization, and identify the patterns and correlations that inform our feature engineering model for the development. During EDA, we discovered the several important insights. For instance, salary varies slightly by the job role. This is the positive correlation between the past experience and salary, and the performance rating is also influenced by the salary level. EDA insights that the first one is age. Most employees are between 22 to 25 year old. The age distribution indicates the young demographic and potentially the early in their career. Then second one is salary. Salary variance is very significant, which is higher salary, possibly due to the experience or high performance performing individual. The median salary is 46781, which is majority of earning between 43418 and 51401. Leave used. Leave is fairly consistent with most employees using 19 to 26 days. The company may have the standardized leave policy that implies to adhere. Leave remaining. The variability of the leave remaining suggests the difference in how employees manage their leave balance. Some employees might not be using their leave, potentially due to the workload and personal preferences. Ratings are generally positive. The most employees are receiving in between 2 to 4. The performance rating system may be the extravagant and resulting in lower overall rating averages. Last one, the past experience. The most employees have very little past experience, as shown by the 25th percentile to 0 years and the median at 1 year. The workforce is predominantly junior, which is many possibly starting their first job. Now, the correlation matrices. These correlation matrices visualize the relationship between the different features in the dataset. Correlation value ranges from the -1 to the +1, where +1 indicates the positive correlation and -1 indicates the negative correlation and 0 indicates the no correlation. The matrices is color coded, with red shaded indicate the positive correlation and blue shaded indicate the negative correlation. The intensity of color reflects the strength of correlation. Feature engineering involves the creating new feature or transforming the existing one to improve our model performance. We derived some features such as tenure, total leaves, and interaction in terms of feature like designation and rating. Data preprocessing prepares the dataset for the model training. This includes handling the missing value, encoding categorical value, and scaling the normalizing feature to ensure the all input data in suitable formats such as for the machine learning algorithm. In this, we use four models. First one, linear regression, decision tree, then random forest, and gradient boosting. For model evolution, we use the mean absolute error, mean square error, root mean square error, and R squared score. Now, first model performance, that is the linear regression. The mean absolute error is the average absolute difference between the predicted salary and the actual salary. A lower mean absolute error indicates the better predictive accuracy. In this case, the average error is around 4.624. And the mean square error is the average square difference between the predicting salary to the actual salary. It penalizes the large error more than the smaller one. Here the mean square error is high due to the square term. And the root mean square error is indicates the proportion of variance of the dependent variable salary that is predicted from the independent variable. And R2 value from 0 to 94 means that approximately 94.19% of the variance in the salary explained by this model, which is quite good. Now the second model is decision tree. The average error is around 5067, which is slightly higher than the linear regression. And the mean square error is higher than the linear regression model, indicating that the decision tree model is more larger error. And the root mean square error, so the average error is around 10017, which is higher than the linear regression model. And the RT value is value of 0.9396 is slightly lower than the linear regression model, meaning that the decision tree explains slightly less variance in the salary. Now the third is random forest model. In this, mean absolute error is around 4697, which is close to the linear regression model, and the mean square error is slightly higher here, indicating the presence of some large error. And in this, the root mean square error is around 111,213, higher than the both linear regression model and decision tree model. And the RT value is lower than the both linear regression model and the decision tree model, indicating that the random forest explain the less variance in the salary compared to the other model. Now the gradient boosting, in this, the mean absolute error is around 4698, is similar to the random forest model, and the mean square error is the highest among all the model, indicating the presence of significant error. And the root mean square error shows the average error of around 11623, which is highest among all the model. And the R2 value is 0.9186, is the lowest among all model, indicating that the gradient boosting explains the least variance in the salary. After that, the model performance comparison. The base model is linear regression model, perform the best in terms of MAE, RMAC, and RT value, indicating that the most accurate and reliable prediction for the salary. Now, second one, the decision tree slightly worse than the linear regression, but still good model with high R2. Random forest is slightly underperformed compared to the linear regression and decision tree, indicating that the model may be overfitting and less suitable for this dataset. Now the gradients boosting show the lost performance in terms of error matrices and RT value, suggests that may not be the best choice of the specific. Now the recommendation, the linear regression provides the best balance of accuracy and simplicity of dataset, which is the lowest among MAE, MAC, and RMAC. That the highest R2 score. The decision tree also performed the well but slightly less accurate random forest and gradient boosting. While powerful, we require the further tuning and feature engineering and potentially outperform the linear regression. Now the project summary, linear regression provides the best balance and accurate simplicity for the dataset, which is lowest among MAE, MASC, and RMAC, and the highest R2 score. The decision tree also performed well but slightly less accurate. The random forest and the gradient boosting, while for powerful, require further tuning for feature engineering and potentially outperform the linear regression. Thank you.